All right, so here we have our second part of the individual competition in 2012. So here we go, number 6. Lauren was born January 7th, and her father said on January 8th, 2050, the year will be 50 times her age then. What is her age 1 week from today? Okay, well, we know that in 2050, she will be some age. I don't know what age that is, so I'll just put a box. And that age times 50 is going to equal that 2050. So, if I'm multiplying her age in 2050 by 50, and I want to figure out this age, I have to undo this problem, and what's the opposite of multiplying by 50? Dividing by 50. So I'm going to divide both sides by 50. 50 divided by 50 is 1. So how many times does 50 go into 2050? Well, it goes into 205 4 times with 5 left over, and it goes into 50 once. So that means we have 41, which is 41 in 2050. Well, if she's 41 in 2050, what year was she born? So go ahead and subtract it out. And so she was born in 2009. And remember, this competition was given in 2012. So in 2012, she will have been alive for 3 years. All right. Number 7. The average of 3 numbers is 5/6. 2 of the 3 numbers are 1/2 and 2/3. What is the third number in lowest terms? So in lowest terms, a little vocabulary lesson, lowest terms means that our answer is going to be a fraction, and we need to get that fraction simplified as far as it will go. So we know that 1/2 plus 2/3 plus some other number, I'm going to show this, and I know it's going to be a fraction, is going to be equal to 5/6. But wait a second. If you find an average, you add up the 3 numbers and then divide by however many numbers you have. So that means the sum of these 3 numbers is going to be 3 times the average. So I'm going to have to multiply this by 3 because in finding the average, I have to divide by 3. Now, normally, I would go ahead and I would cross-reduce this, but I'm not going to do that quite yet. Let's add these 2 fractions together. What number do 2 and 3 both go into? They both go into 6. So, 1/2 is equal to, sorry about that, is equal to 3/6 plus, that's going to be 4/6 plus something. And that's going to equal, well, let's multiply this out. What's 5 times 3? 5 times 3 is 15 over 6. And again, I said typically I would cross-reduce this, but since I knew I'd have a common denominator of 6, it just makes life easier. So 3 plus 4 plus something is 15. Well, what's that something? 3 plus 4 is 7. 7 plus 8 is going to be 15. And when you add fractions, the denominator remains the same. So this number right here is going to be 8/6. But wait a second. The instructions say lowest terms. So we need to reduce this. What goes into 8 and 6? Well, 2 does, right? So we have 4/3. And so our answer is 4/3. Now, in all these math competitions and in algebra, once you get there in middle school, the answers are preferred to be in improper fraction form over a mixed number. And that's something you're going to have to get used to. I know all the way through elementary school they're going to tell you to turn these numbers into a mixed number. But in terms of algebra, you really want the improper fraction. That is the answer. All right, number 8. What is the greatest number of points of intersection that can occur if 4 different straight lines and 1 circle are drawn on the same sheet of paper? All right, so I'm going to show a progression here. I'm not going to get the answer right the first time. I'm just going through thinking on how one might go about doing this. So the first thing I would do is let's just make a tic-tac-toe board. And let's make a circle going around it. So let's see how many intersections I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so that's 12. So is there a way to make it better? Well, I noticed that this line here could also, if I tilt it, I'll do an orange line. If I tilt it, I can get an extra one. So it goes 1, 2, 3, 4, and then 5. So I know that I can get one more by doing that. So that gets me to 13. Well, if breaking this pair of parallel lines gets me one more, that means that breaking this set of parallel lines will also get me one more, and that's going to be my answer. So what's one more than 13? 14. So I know the answer is 14, but the best way to think about it really is, and then I can get one more line to go through it. And so that gives me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there you have it. Number 9. In 1 minute 36 seconds, a car travels 1 mile. At that rate, how far would the car travel in 3 hours? Well, the first thing that we need to figure out is we have minutes and seconds. And we really just want it in minutes. I mean, that would make life a whole lot easier just to have it in minutes, right? So if I have 36 seconds, well, how many seconds are there in a minute? Well, there's 60 seconds in a minute. So I have 1 and 36 sixtieths. Let's turn this into a decimal. What goes into 36 and 60? Well, 6 does. 6 goes into 36 6 times. 6 goes into 60 10. Oh, so this is 1.6 seconds in 1 minute. So it takes 1.6 seconds to travel 1 mile. Okay. Well, how many groups of 1.6 minutes are there in 3 hours? Well, 3 hours has 180 minutes. And so how do I figure out how many groups of 1.6 there are in 180? I divide it. Now, when you divide by a decimal, I know some of us haven't done that yet. When you divide by a decimal, you need to move the decimal place over 1, essentially multiply by 10. And so here's my decimal, here's my decimal. Okay, great. So how many times does 16 go into 18? Oh, it goes in once, right? So there's 16. How many times does 16 go into 20? That's 1. Drop down to 0. How many times does 16 go into 140? Well, it goes in 3 times. No, because 3 times 16 is 18, so it goes in twice. So I'm going to have to work over here on the board. I'm sorry about that. So 40 minus 32. So that's 8. So I have to add another 0. That 0 gets dropped down. How many times does 16 go into 80? Oh, it goes in 5 times. So that means, since there are 112 and a half groups of 1.6 minutes in 3 hours, and we go 1 mile in this amount of time, that means I will go 112 and a half miles. All right, last question, and then we'll be done with this video. All right, as shown, rectangle PQRS is 4 units high and 5 units wide, and we see that on the grid, no problem. Each vertex, that is a corner, of the quadrilateral, quad meaning 4, lateral meaning side, so a quadrilateral is a 4-sided figure, and lo and behold, you have 4 sides. What is the intersection of the vertical? Okay. What is the area of the quadrilateral? Now, you could, in theory, using the Pythagorean theorem, which we're not going to, find this distance and then find the, I mean, it would just be a disaster. So really you don't want to do that. However, if I look at this whole thing, really, I have one large rectangle. I know how to find out the area of the rectangle. And then I have 1, 2, 3, 4 triangles and one square that I can take out of that one large rectangle, and I have my quadrilateral remaining. So really, the area of the quadrilateral, so I'm going to make a little pictorial map of what I'm going to do, is going to be equal to minus all my triangles and that one square. All right, so let's go ahead and do this. Let's find the area of this. To find the area of a triangle, it's the base times the height divided by 2. So we have 2, 3, so that's 6 divided by 2 is 3. 1 times 5 divided by 2 is 2.5. 2 times 1 is 2, divided by 2 is 1. That's just 1. 1 times 3 is 3, divided by 2 is 1.5. So let's add all this together. So I have 3. 1 plus 1 plus 1.5 is 3.5. And I have 2.5. So let's add those together. 6, 7, 8, 9. So that means 9 units are not taken up in the shaded region, and the area of the entire thing is just going to be this distance, 4. So that area of the whole thing is 20 minus 9 is equal to 11.